the normal distribution. So the normal distribution is the most useful probability distribution as it describes a lot of natural occurring data. And all normal distributions are going to look something like this, where we have a bell-shaped curve that's symmetrical about an axis. Now, the probability density function for a normal distribution is going to be expressed in the form f of x equals 1 over the standard deviation times root 2 pi times e to the minus a half, all multiplied by x minus the mean over the standard deviation all squared. And this comes from actually the error function, which is described as y equals e to the minus x squared. And this function here is also bell-shaped and symmetrical about the y-axis. And the integral of this function is actually equal to root pi. And this is where this root pi comes from. It stems from the integral of this error function, and we add in these extra coefficients to help us control how our normal distribution looks like. Because by adding in these extra terms, it helps us shift our graph as needed. Because when we do this, we get our mean that we can shift along the x-axis by moving it, so by having it up here. Because we know from any graph transformation, if we have x minus a value, this shifts it along the x-axis. And this results in the highest point in the graph occurring at 1 over the standard deviation multiplied by root pi. And by changing our standard deviation or manipulating our standard deviation, this can cause our graph to expand this way. Now, some things to note about the normal distribution is that at our mean is also our median and our mode. So all three occur at the exact same place. And increasing this value for our standard deviation will make this curve flatter, and decreasing it will make it taller. So what are some important things to note about the normal distribution? Well, if we have data that's normally distributed, we get some nice results. We get that if we have some mean, one standard deviation above the mean, so the mean plus our standard deviation, and the mean minus our standard deviation, actually accounts for 68% of the data. If we're looking at values between the mean minus 2 times the standard deviation and the mean plus 2 times the standard deviation, this actually accounts for 95% of the data. And finally, if we're looking at values that are between the mean minus 3 times the standard deviation and the mean plus 3 times the standard deviation. This accounts for 99.7% of the data. So for a continuous random variable x, we can define it as the normal distribution of the mean and the variance. And we'll have a look at more of this in an example. So let's say we have a score x of a test done by a student. So the score x is represented the score of their test. And it was found to follow a normal distribution relating to a normal distribution of 34,25. We want to find the range of scores. The range of scores in the middle, 68%. So we know from this that our first value here is equal to our mean. So we know our mean is 34. And our variance is the second term, which is 25. Which means if we just square root both sides, we'll get our standard deviation equaling to 5. And it helps to draw up a little graph showing what's going on of our normal distribution. So let's go ahead and do that. So we've got our normal distribution in the shape of a bell curve. And we know the mean is equal to 34. And let's look at one standard deviation on either side. So we know standard deviation is 5. So this point here must be 39, and this point must be 29. And this accounts for the middle 68%. So we know the answer to the range of the scores in the middle, 68%. That would mean that the score in the test should be in between 29 and 39. What about second question? We're after the percentage of students that would get a score that was greater than 44. So let's again go to our graph. And we know we can keep adding and subtracting standard deviations on either side. So another standard deviation of 5 would get us to 44. And one below would get us to 24. And we know for this whole section here, this accounts for 95% of all scores. Which means that these leftover parts account for the remaining 5%, and because they're distributed evenly, this has to be 2.5%, and this has to be 2.5%. So the percentage of students getting greater than a score of 44 is just going to be 2.5%.